we're going to look at 113. 113 is Cactus Junction, which is a pretty complex word problem. It's a lot easier to see this if you're actually drawing it out. So John is 60 miles directly south of Cactus Junction. So let's say this is Cactus Junction. John starts down here. He is moving this way at a rate of 60 miles away. He's traveling 40 miles an hour, so we'll call this 40 times our time. And we're going to subtract 60 because he's 60 away. Okay, 60 away from Cactus Junction, but he's moving towards it. And then Amy is headed east, and her rate, or her speed, is 30 miles an hour, so it'll be 30t, and she's 20 miles from Cactus Junction. Okay. So this answers question A here. This answers question B. We got our two rates. Then it says find the distance between their cars. Now, you can imagine that they are moving towards Cactus Junction, so this triangle, as time moves on, is going to get smaller and smaller, right? Okay. But we need to find an equation to represent this changing distance. Now, it all depends on the time, how far they've driven, so it's going to be variable. How long they've driven, excuse me. Well, if you look at this, you can see that there's a right triangle here, which we can think of as A, B, and here's our C, which we will call our distance. So, you have the Pythagorean theorem. A squared plus B squared equals C squared. Now, I'm going to write it down here because I'm kind of out of room. So if we go ahead and we're going to call this d of t, our distance in relation to time. So distance in terms of time squared, it's our c squared, equals 30t minus 20 squared plus 40t minus 60 squared. Here you see it again. Here's the a squared, b squared, plus c squared. Alright, now to get our distance alone, we need to square root it. So our distance function in relation to time would be the square root of 30t minus 20 squared plus 40t minus 60 squared. And that is the answer for C. You can see it's going to change based on how far they've driven. Question D asks, when are John and Amy's cars closest together? You need to put this in your graphing calculator, and you're going to look for the lowest point. It will end up forming a quadratic. It looks something like this. And since your y-axis is distance, d of t, and this is time, we want to find out when they're closest. It will be this lowest value, this lowest y value, which ends up being about 20 miles apart. Okay, we can look at that in class. The algebra is what I want you to focus on, though.